Welcome to part 3 of the product demo series, Sequences and Target Planner. In the previous video, part 2, SOLIS subsystem configuration, we added sensors, actuators, and actuator sets to the SOLIS configuration. We were then able to configure the attitude determination system and tune the attitude controller. Then we configured the power subsystem and visualized the max telemetry of these new components during a simulation. In this video, we will dive into the sequencer as well as the SOLIS Target Planner. So let's get started. We will start by opening up SOLIS. This is the same configuration that we have been working with over the last two videos. We're going to click on Mission Sequence Definition and go over to our Sequence Editor tab. The Sequence Editor is one of a few places where we can create FlightJazz sequences. To start, we'll see our sequence library is empty, so let's add a new sequence. We'll call it Demo. Now the right pane has opened up to us so we can add elements to this sequence. There are 4 element types that we can add: spacecraft command, raw code to write the FlightJazz code directly. We'll talk about that more later in the video. An embedded sequence and a comment. So we're going to do a spacecraft command and we'll add it. Now we'll see that every command that is available to us with our configuration to max is listed here. What we want to do is, now that we know that our simulation begins in an idle control mode, we'll command a different mode. So let's go to the mode controller, slew to tracking, and now that we have selected a command, the command arguments have populated on this lower right pane. We are going to fill this out. So the slew time, we're going to leave it 0, meaning the optimal slew will be calculated. For the slew mode, we're going to select rendezvous. For the track mode, let's command nadir track. And for the clocking option, we'll use spacecraft orbit normal. Now that we have this command all set up, the last thing to do is to select when this command will be executed within the FlightJazz sequence. Right now we have it set at 0. So let's give it a little bit of time so we can see what's going on and set it to 60 seconds. We'll accept those changes. And let's add in one more command. Let's do another tracking command. We'll leave the slew time at 0 again. For slew mode, we'll use that rendezvous. For the track mode, let's use a sun track. And for the clocking option this time, let's use the spacecraft velocity. Now we have it executing at the same time as the nadir track, so we want to give it a little time to achieve nadir track before commanding a new mode. So let's say at 360 seconds, we want this command to execute. Now that our FlightJazz is all set up and ready to run, let's go over to the sequence selection page. From our sequence library, we're going to see our demo sequences here. So let's add it to our execution list. We have a couple options for the execution condition for this sequence. We can have it run after previous for a set time or run at an absolute time. We're going to leave ours at run after previous and leave it at 0 seconds so that it begins executing as soon as max executes. Let's accept those changes. We'll move SOLIS to the side so we can see what's going on. And we're going to run at a multiple of real time. We'll use the 10-time multiplier. Select OK. Now the run status screen is popped up and max is executing. We began in idle mode. We can see that we have no rates or momentum. Here at 60 seconds, that nadir track command has been sent. We can look at the command history and see that that was sent, as well as the event messages. The spacecraft is now about to achieve nadir track. We'll see that in the spacecraft mode here. And at 360 seconds, we told the sequence to execute a sun track command, so that's going to execute right now. We're seeing the spacecraft respond to that command. We can also see it in the command history. So now that we've seen that we can create sequences to automate commanding during a pass, let's go ahead and stop the simulation and take a look back at SOLIS to kind of see what has been going on. So if we bring SOLIS back over here, and we click on the Raw Sequence Editor tab, we can see the FlightJazz code that SOLIS wrote for us from the sequence editor. We have our wait for the 60 seconds to send the nadir track command, and then our wait for the 360 seconds to send the sun track command. So without needing to know how to write FlightJazz code, SOLIS wrote it in the background utilizing the sequence engine. You can also create raw sequences directly from this page and handwrite the FlightJazz sequence. We also offer a FlightJazz editor that is free in VS Code to be able to write these sequences. So now let's take a look at the sequence engine configuration. From here we can set what our execution rate is of our sequences. We can also set the number of sequence engines we have configured, which is the number of sequences that can be running in parallel, and the maximum statements per frame that can be executed within our sequences. So now let's take a look at the Target Planner. The Target Planner utilizes SDK objects in order to generate an optimal target plan based on user configuration. So to demonstrate this, let's go ahead and close SOLIS. And we're going to reset our scenario. And let's start by adding a sensor object to our spacecraft. And let's call this sensor object an imager. And let's narrow the field of view a little bit to make it easier to see what's going on. So we'll bring it down to 20 degrees. And we are going to add in two target objects. So let's enter in two defaults. So that's one, that's two. And then let's also add in a facility. There's our facility. Okay, so now let's rename this to image 1. And the other target is going to be image 2. And our facility, we're going to name our ground station. Now we need to place them where we want them. So let's say that our first image we want right under our orbit track in the northern part of America. And for our second image, let's move it a little bit off of the ground track here. And those are the two locations we're going to take an image. And then let's select where we want our ground station to be able to downlink that data. So let's put the ground station right here in South America. So now that we have our SDK scenario configured, let's bring SOLIS back up. The first thing that we need to do is to configure the payload in SOLIS. So let's click on our Payloads tab. We'll add in the payload. We'll name this payload imager. And we're going to link this payload to the SDK object imager that we put on our satellite object. What this will do is when we command a mode for this payload in Max, the visuals of that payload's field of view in SDK will begin to flicker. So now we need to add a mode. We're going to make the mnemonic image. And we'll call the mode name image as well. For the mode power, let's say it takes 300 watts. And for the data output, we'll call it 764,000 bits. We'll accept those changes. Next thing we need to do is to be able to downlink this data. So we're going to create a communication system. So we'll add the communication system. We'll leave it at its default name of consystem. We don't have an SDK object to link it to. We'll make it both a receiver and a transmitter. And we'll just leave it at the default rates and power. And if we go back to our power and thermal page, we'll see that payloads are a variable load. That means that when we do payload operations, we're going to see the spacecraft load increase. And we also have communication systems as a variable load. So we'll see that when we're downlinking data, that the wattage that we said it takes to transmit data is 18 watts, and we'll see that reflected in the spacecraft load. So next thing we need to do is add this telemetry for our communication system. So we're going to go to Odyssey Data Management, and we're going to see that we have both our comm system and our imager. So we'll add that packet group. We'll accept those changes. And now the last thing we need to do to get ready to use the target planner is to create sequences for what we want to happen when we arrive to take an image and when we leave that location, as well as how to communicate with the ground station. So we're going to add in a take image sequence. For this sequence, we'll add the spacecraft command, and we're going to reduce mode controller. And first thing we need to do is to turn our imager on. We'll add in another command now to set the mode of the imager. And this is the mode that we created in the Payloads tab, so this is image. And we're going to accept those changes. Now, when we leave the site that we want to take an image, we need another sequence to put the imager in standby. So we'll make another sequence, imager standby. We'll add in a command for that. Go to the imager power mode, and we're going to set it to standby. Next thing we need is a sequence for what happens when we get to the ground station. So we'll make a sequence called downlink. We'll add in a command for that. And for our comm system transmitter, we're going to set the state to on. Okay. And then when we leave the ground station, we want the comm system to be in standby. So we'll make that sequence. Add in a command, go to transmitter state, and we'll change that to standby. So now that we have all of our sequences set up, we can now go over into the target planner. First thing we need to do is to load in those SDK objects that we created. So we'll click on the action, load SDK target objects, and execute. So now we'll see that we have our ground station and our 2 image locations. In order to tell the target planner what we want to do at each of those targets, we need to set up targeting configurations. So we'll set up one. We'll name it take image. We're going to set our options for minimum dwell. We'll say it needs at least 5 seconds to take an image, but the desired dwell is 60. And to point at that target, we need to set up our slew mode. We'll select the Ronde slew. And for our destination mode, we're going to set up target track, which we know from the mode controller page is going to point the Z-axis to the target. And our clocking source, we'll make it spacecraft orbit normal. Last thing is, what do we do when we arrive to a take image target and when we leave one? So the on target sequence is going to be take image, and the off target sequence is going to be imager standby. Okay, we're going to accept those changes, and we're going to make one more targeting configuration. This one is going to be called downlink. And for downlink, we want at least 60 seconds on the target with a desire of 600 seconds. We are going to rendezvous to a target track. And our clocking source will be spacecraft velocity. The on-target sequence is going to be that downlink sequence we created. And the off-target sequence is going to be comm standby. And we'll accept those changes. So last thing is, we tell the target planner which targets have which targeting configuration. So for the ground station, we want downlink, so we'll apply that. For the image locations, we'll select them both, select take image, and apply that. We'll accept those changes. So now we need to generate the sequence. So we're going to click execute. We're going to call this our target plan. Save that. Now the target planner is running, calculating access and figuring out the optimal conditions for this new sequence. It has finished generating the sequence, so we'll hit close. We see the target planner results summary here. We'll click OK, and we'll accept those changes. So now if we go take a look at what did the target planner just do, we can look at it in the raw sequence editor under target plan. Or we can go to the sequence editor and look at the target plan. From here, we can see the sequence that the target planner created for us in order to collect on all of our targets and run all of the sequence that we selected for those targets. So we can visualize what this did. Let's go to sequence selection. We're going to remove demo from our execution list, and we're going to run target plan right away. So let's move SOLIS to the side here, and we're going to run at 10 times real time and take a look. So if we look at our spacecraft status, first of all, we'll see that now we have payload and comms sections populated. And clicking on our command history tab, we can see that a slew was commanded in order to point the spacecraft at the first image location. We can change our perspective a little bit to see that the spacecraft is aligning with that image location. And looking at the payload and comms section, we can see that the imager is about to turn on, and the data recorder is increasing in size from that image, as well as the spacecraft load increasing from the payload turning on. The payload just turned off, and a slew has been commanded in order to collect on the second image location. Now we didn't have any constraints, so it just is pointing due to line of sight. The imager is back on, and our data recorder increased in size some more. We're now going to see that the spacecraft is slewing to the ground station, and we can change our perspective to take a look at the ground station. The spacecraft has about arrived on target, and we're going to see the comm system just turned on, and the data recorder is emptying. So in this video, we covered sequences, how to create our own sequences through the sequence editor, as well as the target planner's ability to write sequences for us for any number of targets that we have selected. In our next video, we are going to introduce the Max Ground Data System, as well as its ability to communicate with SOLIS in a true test-like-you-fly way.